Hello everyone, this is Professor Krishanu Biswas from IIT Kanpur, and I am going to give you a brief introduction of NPTEL MOOC on deep learning and material science engineering from concepts to applications. Let's take the big picture before we get into details of this course. Deep learning is widely used now by the tech giants, talking about Gemini by Google, ChatGPT by OpenAI, or even Anthropic softwares. Deep learning is world pervasive. It is used in various aspects of daily life applications. You can use in your mobile phones also. So what is deep learning then? For a beginner, deep learning handles complex data and it uses deep neural network. Human brain has neurons. We can mimic this concept of neurons and form deep neural networks. And using complex data, we can solve various kinds of problems and predict their behavior. So therefore, two things you have to remember about deep learning. One, complex data. Second, the deep neural network. The question is, why deep learning in material science and engineering? Well, those of you who have simple idea of material science engineering, they know the material science engineering involves a lot of complex problems. Starting from synthesis to characterization, property estimation, correlation between microstructure and properties, these are very complex systems. And we have a lot of data. Last 100 years of research has provided you a lot of data. So we don't have a problem of complex of data, but we have to utilize the concept of deep learning to solve various kinds of problems. That's why you are interested to know how we can apply deep learning in material science engineering aspects. So hope you understand that. Many of you have done my course on artificial intelligence and machine learning in material science engineering. This course is a new avatar. This has not much similarity with the earlier course except the basic concepts. So let's go into the details of this course, how we can deliver about that. So what are the objectives of the course? This is very important. When you start taking the lectures of the course, you must know what are the takeaway, what are things you will be learning if you do this course after 30 hours of lectures. First, this accelerate the simulations, replace or heavily augment the computationally expensive ab initio calculations like density functional theory or molecular dynamics simulations. And how it does it? Using these deep learning models. That's the idea. Secondly, it can map properties to structure. I have already mentioned one of the critical problems of material science is to connect the microstructure with properties. So therefore, deep learning allows you to learn how to use these neural networks to connect the atomic and molecular structures of materials to their macroscopic, functional and mechanical properties to give an idea what is conductivity, mechanical strength or other things like solubility. Third important aspects of these objectives are to handle unstructured data. Structured data is very easy to handle using machine learning, but complex data modalities like atomistic point clouds, electron microscopy images, spectroscopy images, or even natural language text, which are available in open literature. How do you handle that? Deep learning allows you to handle that. Last but not least, you can design new materials with new chemistries. Using generative models like generative adversarial network, what is called GAN, or diffusion models, we can actually create new crystal structures and molecules. So in a nutshell, you can solve very complex problems using deep learning methods. So let's talk about the details of this course. We're going to introduce this course simply by introducing deep learning concepts in materials engineering, giving you some case studies where it has been used, and what are the advantages of using that. Then directly we went to the foundations. Foundation means basically deep neural networks. So we will start discussing about the discussions of foundation will begin with the deep neural network, perceptrons, multi-layer networks, what are the gradient descent, optimizers, regulations, and in case of multi-layer neural networks, single network layer versus multi-layers. Then as we know, material scientists use a lot of images, electron microscope images, optical microscope images, or even other microscopic images. So hence we must know details of the convolution neural network or CNN, the architectures and the models including AXNet, BGG, ResSet, GoogleNet, many others, transfer learning and ensemble modeling also. Fourth aspect which you learn is explainable AI in vision. Explainable AI vision is very widely used now. It's basically deep dive technique like LIME, SHAP, occlusions, GateCam, guided backpropagation applied to CNNs that will be taught as a part of these particular portion. Fifth one is obviously segmentation and object detection. There we use various high order deep learning models like LSTM, GRUs. In addition, we will talk about UNet, attention, UNet, YOLO, faster CNN, and hands-on experience on labs, etc. Then we move on to what is known as natural language processing, NLP. Talking about text preprocessing, embedding including W2, Word2Vec, Globe, and sequence modeling. And obviously, we must talk about autoencoders and transformers. ChatGPT T transport transformer, right? So P-trained transformers. So therefore, you must know what the architectures of these autoencoders, self-attention, in-context learning, and self-supervised methods. At the end, we'll talk about large language models, which are very, very widely used now. Reinforced learning for fine-tuning, deep generative models like VAEs, GANs, and diffusion models. So this itself is basically 30-hour lecture. Hope you will be able to take a lot of things with you. So now the question is, what are the advantages of doing this course? If you are a student or researcher, you will like to know these concepts to apply in your new material design, understanding the phenomena between microstructure, connection between microstructure and the material properties, and also synthesizing new materials. If you are an industry professional, you need to upskill. You may have learned some idea or something about AI or ML, but deep learning will provide you the boost to go forward. You can even take a knowledge of these and move into different kinds of AI platforms. And if you are simply want to learn as a beginner, this will give you a good perspectives of what deep learning can do in materials engineering and what it cannot do. It can solve all the problems, but obviously it cannot solve everything. Please try to understand that. So with this, I like to welcome all of you, and please enroll. This course will be offered in next semester in July 2026, and we'll be also having a lot of TAs. I like to point it out that in this course you are not only want to gain about concepts, but you will also gain about applications. Not only you will learn about autoencoders, you will learn how to make an autoencoders. Not only you will learn about CNN, you will build your own CNN. So as a part of this course, TAs will give small snippets or lectures on how to build this kind of architectures, so that your learning is complete with theory as well as hands-on experience. You will be gaining a lot of knowledge which can be used further for your studies or applications wherever you are. So again, welcome you and thank you.